Hello, my name is Drama Khan and I'm here to teach you guys Chemistry 5070. Let's start with today's topic, the particulate nature of matter 2.3. We're going to start with structure and properties of the materials. I'm going to discuss the differences between elements, compounds, and mixtures, and then I'm going to share some simple molecular substances, their structures with giant covalent substances. How do they both compare? And I'm going to also share the bonding and structures of diamond and graphite. So let's begin. First, I'm going to tell you what is basically an element, compound, and mixture. So we all need to know about certain differences between all the three of them. So elements, they are substances which they cannot be broken down into simpler substances, and they consist of only one kind of atom. So you can see that elements, they have only one kind of atom, and they will not be broken down into more simpler substances by any kind of means, by physical or chemical means. Whereas if I talk about compounds and mixtures, they are made up of atoms of two or more different kind of elements. They are bounded together by the chemical bonding, and if you want to separate the components of a compound, you can separate them by any chemical means. You can separate the elements by any chemical means, but they will not be separated by physical means. Whereas if I talk about mixtures, they consist of two or more different elements, and they are combined together physically. If you want to separate them, you can separate the components by physical means, and you will not need any chemical means to separate them. Coming to these elements, they are substances, as I told you, that they cannot be broken down into simpler substances by the chemical reactions. And elements can be of two types, metallic and non-metallic. If I talk about metallic elements, they are represented by atomic symbols. For example, the metals, they are present on the left hand side of the periodic table, whereas this is a representation of a periodic table. So this side is the left hand side, which is made up of metals, whereas the non-metals are present on the right hand side of the periodic table. Non-metals, right? So metals on the left hand side of the periodic table, they are represented by the atomic symbols. For example, iron, sodium, calcium, they are all represented by their atomic symbols. Fe, iron, sodium, Na, and calcium, Ca, Mg for magnesium, right? But if I talk about the non-metals, they exist as molecules. And this is what molecules is all about. Molecules, they are made up of two or more atoms, but they are of the same element. For example, if I'm talking about the atoms, they are going to be separate. If I'm talking about the molecules, they are going to be two or more atoms, but they will be combined together, and they will be of their same element, and they are chemically bounded together. So these are molecules. This image is of a molecule. For example, it can be nitrogen, it can be oxygen, it can be chlorine, N2O2, Cl2, and molecules, as I told before, that the non-metallic elements are on the left hand side. But if I talk about the group 8 elements, they consist of the noble gases, and they exist as separate atoms. So they will exist at these separate atoms. Okay. For example, helium, argon, neon, they will all exist as separate atoms. Ne, neon, helium, He. They are also on the left hand side, but they will exist as separate atoms, and they are represented by their own symbols. Now the compounds, they are chemically combined together, and they have two or more elements, and they are combined in fixed proportions. So they always contain the same ratio of its component elements, whereas the mixtures, they have different ratios of their component elements. If I talk about the properties of the compounds and the mixtures, the compounds, they have different properties from their component elements. For example, carbon dioxide. Carbon and oxygen both have different chemical and physical properties. But when they both are combined together and they form a carbon dioxide gas, they are going to have different properties, and carbon dioxide gas will have different properties. Mixed, for example, if I talk about mixtures they retain their properties of their own component elements. So this is the difference between all three of them. One more thing over here in the diagram I wanted to show. As you can see, these are the atoms, these are the molecules, they are of the same element. Compound has two or more different atoms which are chemically combined together, as you can see over here in the image. In mixtures, you can see we have molecules as well, we have atoms as well, and we have compounds as well. So this is a mixture because it has different different components, and they are physically combined together. If you want to separate them, they will be physically separated. Coming on to the next slide now. So now I'm going to discuss with you some simple and giant molecular substances. Now, simple molecular substances, they can be hydrogen, oxygen, they all, iodine, methane, carbon dioxide. Now, they all have weak intermolecular forces. First of all, in a molecule, within a molecule, they have intramolecular forces within a molecule, and in between the molecules there are intermolecular forces. So these are intermolecular forces, and within a molecule is the intramolecular forces. So intramolecular forces are more stronger as compared to the intermolecular forces, which are weak, and they're also known as van der Waals forces. If I talk about iodine, supposedly this is iodine, this is I2. So I2 molecules, they are going to have weak intermolecular forces between them, and if you want to break them, they will be easily broken down, and only small amount of energy will be required to break them down. So they will be highly volatile, and they will have low melting and low boiling points. This is the reason, if someone asks you why do they have low melting and boiling points, the reason is that they have low melting and boiling points because only small amount of energy is required to break their intermolecular forces because they are weak. Whereas if I talk about giant covalent substances, they have high melting points because lots and lots of energy is required to break their strong covalent bonds. So they have strong covalent bonds in between. For example, diamond, graphite, silicon dioxide, right? Let's come to the next slide now. I'm going to discuss some physical properties of these compounds. Now, simple molecular substances, they are solids, liquids, and gases at room temperature and pressure. The liquids and gases at room temperature and pressure, and they are highly volatile. They are going to evaporate very easily because their weak intermolecular forces. They are broken down easily at room temperature and pressure. This is why they are solids, liquids, and gases at room temperature and pressure. They are solids at room temperature because if they are if they are large molecules, they are going to be solids. If they are smaller molecules, they are going to be liquids or gases. For example, water and carbon dioxide. Simple molecular substances, they also have low melting and boiling points because they only need small amount of energy to break their weak intermolecular forces. If I talk about giant molecular substances, for example, silicon dioxide and graphite and diamond, they have higher melting and boiling points. Covalent substances, they do not at all conduct energy. They will never ever conduct energy because they do not have any free moving electrons to conduct energy. all of their electrons are used up to be shared between the atoms. So except the graphite, and there is another exception for the covalent substances. If there is an acid and acid is dissolved in water, what is going to happen? It is going to form an aqueous solution of acid. When the acids they are added into water, they will form an aqueous solution of the acid, and the bonding will convert into an ionic bonding. Why? Because the ions are going to dissociate, and when the ions are there, the electrons they can carry charges. The free moving electrons can carry charges, and that is why they will be able to conduct electricity. So this is an exception over here. Coming to the next slide now. Now I'm going to compare the structures of graphite and diamond. Before this, I'm going to tell you one more thing about allotropes. Now allotropes are, let me share it here. What are allotropes? Allotropes, they are of the same element, but they have different structures. So if the element is the same and they have different structures in the same physical state, it will be known as an allotrope. So they have the same element, but they have different structures. For example, oxygen, O2, and O3, ozone. So they both have the same element, but they have different structure. So they are both known as allotropes. If I talk about graphite and diamond, they are also allotropes because they have the same element, that is carbon, and they are in different structural forms. That is why they are known as allotropes. Now coming to the differences between the graphite and diamond, and then I will share with you the physical properties. Graphite has carbon which is directly attached to three or more carbon atoms. So if you see over here, it has one carbon atom which is joined to three more carbon atoms, and it is forming a hexagon. A hexagon is 6 sides. So it is forming hexagonal structure which is layered. And whereas if I talk about diamond, diamond has one carbon atom which is joined to four more carbon atoms. So it has a tetrahedral structure. So this one is a 3D structure, whereas this one is a graphite has a 2D structure. So diamonds do not conduct electricity because all of the electrons they are used to share between the different atoms. Whereas in graphite, it has each carbon has one electron which is not shared. So when one electron is not shared, so that means they have free moving electrons, so they can conduct electricity. So graphites can conduct electricity, whereas diamonds they cannot conduct electricity. As I shared that graphites they have layers as well. So as you can see that the layers of hexagonal layers are formed in these in the structure of the graphite, and in between the carbon atoms we have covalent bonding, whereas between the molecules we have weaker binding forces or weak intermolecular forces which are known as also van der Waals forces. So these these layers they can slide over each other, which is why they the graphite is very soft and they can be used in as a lubricant. Both the structures they have the same formula, carbon C. Now coming back to my last slide, so I will share with you the physical properties. Here, as I shared, graphite has a lower melting point, whereas diamond has a higher melting point because it is hard, and it has a stronger covalent bonding as compared to graphite. Graphite has some van der Waals forces or weak intermolecular forces, which is why it has a slightly lower melting point as compared to diamond. Graphite can conduct electricity, whereas the diamond cannot conduct electricity because there is no free moving electron. If both are burned, they both are going to produce carbon dioxide. When both are burned, both are going to produce carbon dioxide, as both are made up of carbon. And when they're going to be combusted, and they're going to go through a process of combustion, they're going to produce carbon dioxide, CO2. So one more thing. Now the uses of graphite. Graphite can be used as a lubricant because it has sliding layers. It is soft and it is very smooth. When it is baked along with clay, it will form pencil lead. So if you have more graphite in pencil lead, pencil lead is going to be more softer. Why? Because it has a property, graphite has a property of being soft. Whereas if I talk about diamonds, diamonds have shiny and they are used in jewelries. They have greater refractive index as well. They are very hard, that is why they're used as in drilling and in glass cutting as well. So these are different uses of diamond and graphite and the properties of according to their structure and bonding. I'm going to share some other questions with you guys now, so you have a much clearer idea of how to solve some MCQs during your papers. So let's discuss some practice examples here. The first one is, which statement shows that graphite and diamond, they are different forms of the element carbon. So you have to tell that graphite and diamond, they are of the same element carbon. How are we going to get it? How are we going to know that they are from the same element carbon? And they are only the different forms. Now let's read the statements. The first one is, both graphite and diamond, they have giant molecular structures, complete combustion of equal masses of graphite. So see, first one is that they have giant molecular structures. Giant molecular structures doesn't go anything with the same element being the same element carbon. Graphite and complete combustion of equal masses of graphite and diamond produces equal masses of carbon dioxide and no other products. Now let's see over here. Graphite and diamond, they are both formed from carbon. And when they are going to be, when anything made up of carbon is going to be combusted, when it's going to go through the process of combustion, it's going to produce carbon dioxide. And you see that they have given you a hint that it is not producing any other product. When it's not producing any other product, that means that this element, this substance has to be from the same element carbon, right? So the first one was wrong, but the second one is going to be correct. Now we have the third one. The third one is that it has both has different melting points. This doesn't go with anything like they have the same element carbon. It doesn't do anything with that. Graphite conducts electricity, whereas diamond does not. Now see, these are the different properties, but they don't go with being the same element carbon. So only the statement which is correct is going to be B. Now, which is a compound? With air, carbon, oxygen, or steam? Carbon is an element, as we know. Oxygen is molecule, right? Steam is H2O, a compound, molecular compound, and air is a mixture of gases. So which one is a compound? Steam. Coming to my next one. Now here, this statement is showing and explains why magnesium oxide has a very high melting point. So magnesium oxide, the first statement states, magnesium atoms and oxygen atoms, they are joined by strong covalent bonds. Now see, melting point and boiling point is all related to the bonding of the substance or of the molecule. It depends all on the structure. If it has stronger bonding, then that means it has a high melting and boiling point. So this always has to do with something with the stronger bonding means increased melting point and boiling. So the second one is the crystal lattice of magnesium oxide. It resembles that of the diamond. This doesn't have to do with anything with the bonding. Now, and even the magnesium oxide MgO crystal lattice does not at all resemble the diamond, so this is going to be wrong. The magnesium ions, they are strongly attracted to the oxide ions. No, um, the reaction between the magnesium and oxygen is strongly exothermic, does not have to do anything with the exothermic one. So it's always going to be A because we are always concerned with the bonding. In which pair of the substances does each? So each means both of the substances, they have a giant molecular structure. Now see over here. Diamond is a giant molecular structure, iodine is not. Sand, silica, and diamond both are giant molecular structures. Both are correct. Iodine and methane both are not at all. They both are simple molecular structures. Methane is a simple molecular structure and silica is a giant molecular structure. So both in which are correct is only and only B. So which material has the highest melting point? Now highest melting point, it is always concerned with the bonding. Now if I tell you this, that ionic bonds, they are always stronger than covalent bonds. So their melting points are also going to be more energy will be required to break them down. So it's going to be much more higher. Which one is a ionic substance then? Ammonia, no. Methane, no. Water, no. They all are formed by covalent bonding, and I will share this more in my next two lectures. So sodium chloride, NaCl, is an ionic substance, and I will share more about ionic and covalent substances in my next few lectures. So this one has a high melting point because ionic substances have they have stronger bonds as compared to covalent. In case it is a giant covalent substance. So no one over here was a giant covalent substance. So NaCl has a giant lattice, ionic lattice. That is why this one is going to be the correct. I will share some more things differently with the ionic, covalent, and different bonding. We are going to cover different types of bonding in my next few lectures. So until then, thank you so much. If you guys have any other questions, please comment down on this video below. If you have any queries, and I will reply to them. If you have any other questions and you're practicing any more questions from your past papers, you can even ask me in the comments below, and I will reply to them. Inshallah, please be stay tuned and stay with us, and please give us some comments if you like them. If you have some any other suggestions, you can tell us, let us know. Thank you so much. Happy learning.